This video is going to teach how we add and subtract radical terms. So radical terms, of course, are terms that have radicals in them. Now, we did a video before on how we simplify radicals, and we know that multiplying radicals, we can actually multiply the radicands. For example, the square root of 2 times the square root of 3 is equal to the square root of 6. However, we're going to be doing something a little bit different. We're going to be adding and subtracting radicals. So for example, square root of 2 plus the square root of 3. What is it? Can we use properties that we've learned before? Well, first of all, can I say that it's the square root of 5? Does that make sense? Can I just add the numbers that are inside? The answer is no. And let me actually prove it to you guys. What if I have the square root of 1 plus the square root of 1? We know that the square root of 1 is 1, and the square root of 1 is 1, so if we add them together we get 2. So that's our answer. However, if I try to use this rule, I end up with the square root of 1 plus 1, which is the square root of 2. And so we notice that these do not agree with each other, right? These are not the same. So this rule is in fact wrong. Okay, definitely wrong. So the way that we deal with adding radical terms is to add radical terms as if the radical is a variable. So what do I mean by that? Well, like when you add variables together, we can only add radicals that are like terms. We call them like radicals. So let me write that down. Like radicals are radicals with the same index and the same radicand. For example, cube root of 3x and 4 times the cube root of 3x, those are like radicals. Or for example, the square root of 10 and 2 times the square root of 10. Those are also like radicals. So how do we add like radicals? This is what we're trying to figure out. Well, let's look at, for example, adding something like 3x plus 7x. We know that when we add these terms, since they're like terms, we can just add the coefficients together. This becomes 10x. Now let's notice the analog here. Let's say instead of an x, that was a radical x plus 7 radical x. Well, guess what? It's the exact same thing. This becomes 10 radical x. Or if this was 3 root 2 plus 7 root 2, we get 10 root 2. So hopefully you're getting the idea. The idea is that you treat it just like variables, and you can only add them if they're the same radical. So to add or subtract, radical terms, step 1 is going to be to simplify all radicals completely. Step 2, add or subtract like radicals by combining their coefficients. Okay? So these are going to be the two steps, to simplify the radicals and then to add or subtract the radicals, terms that are the same radicals, by combining their coefficients. Alright, so let's go ahead and do some examples. The instructions are going to be to add or subtract and simplify. So step 1. 6 plus 3 root 5 minus 2 minus root 5. What we're going to do is we're going to combine the like terms. So first of all, 6 and 2 go together. 6 minus 2 gives us 4. And then we have positive 3 root 5, negative root 5. That gives us positive 2 root 5. And that's it. We cannot combine any further because these are not like radicals. They're not like terms, right? Okay, let's try another one. How about the square root of 27 minus the square root of 3? Well, before we can say that we can't combine these, which we can't right now, notice that the left radical is not simplified. So let's recall how to simplify radicals. We take the 27 and we rewrite it as a nice piece and a leftover piece. The biggest perfect square that goes into 27 is 9, so the leftover is 3. So we get 3 root 3, which gives us 2 root 3. In case this does not seem familiar, you might want to go watch the video that we have on simplifying radicals, since that's where we learn how to do that. But yes, the goal is simplify first, then combine the like radicals. Alright, let's try another one. This is going to be problem 3. 3 root 20 plus 2 root 12 plus 6 root 5. Okay, let's see what's going on here. First, don't forget to bring down the 3. Now, 20 can be broken down into 4 and 5. Don't forget to bring down the 2. 12 can be broken down into 4 and 3. And then we have this guy. Now we simplify the radicals. Square root of 4 becomes 2. Square root of 4 becomes 2. And that one stays the same. And finally we have 6 root 5 plus 4 root 3 plus 6 root 5. Now, once we're simplified, we look for the ones that are the same. This and this have the same radical. We end up with 12 root 5 plus 4 root 3. And that's it. That one was a little bit tougher because we could simplify 2 of these guys. Alright, let's do some with variables thrown in. 10 square root of t minus square root of t. Now, because they're the same radicand, we can go ahead and subtract. 10 root t minus root t gives us 9 root t. Alright, let's do another one. Let's get a little harder here. Square root of 12n plus square root of 3n. Remember, there's nothing we can do up front here because they are not the same radical yet. So I'm going to break it down into 2 pieces. Remember, the nice piece and the leftover piece. Now, the nice piece, the biggest perfect square that goes in is 4. And that's it. All the rest is going to go here. And for square root of 3n, there's nothing I can do with that. So this becomes 2 root 3n plus root 3n. That gives us 3 root 3n. And that's it. We're going to do a few more. Let's get harder here. Square root of 5z squared minus 3z square root of 20. Now this is tough because these radicals do not look at all like they're the same, but we need to simplify first. So we need 2 pieces, the nice piece and then the leftover piece. Now for the nice piece, looking at the variables first, the z squared, since it's already even, we can put all of it in here. All the rest is going to go here. Now for this part, we have a 4 and then a 5. So this becomes z root 5 minus, and this is 3z times 2 root 5. So we get z root 5 minus 6z root 5. Now notice they both have a z root 5. The first one is a 1z root 5 minus a 6z root 5. That gives us negative 5z root 5. And that's our answer. Let's try one more, this time with cube root. This is going to be the hardest one. 5x times the cube root of 16x cubed plus 4 times the cube root of 2x to the 6th. Okay, we always rewrite the 5x here. Now we have two radicals here. First, with the 16x cubed, first we look at 16. The largest perfect cube that divides is 8. Left over is 2. And x cubed is divisible by 3, so we put all of it here. Now the next one. We have the nice and the leftover. All the x's are going to go in here because 6 is divisible by 3. The leftover goes here. So what do I end up with? I have 5x times 2x and then a cube root of 2. 5x times 2x is 10x squared cube root of 2. Now on this one we have 4x squared cube root of 2. So let me rewrite that here. 4x squared cube root of 2. Now because they both have an x squared cube root of 2, you combine the like terms, you get 14x squared cube root of 2. And that's it. Be really careful, by the way, on how you write this, because the x squared and the cube root of 2, the 2 and the 3 look like they both might be exponents unless you're really clear that the 3 goes with the cube root and the 2 goes with the x. And that's it for this video. I hope it was useful. Again, practice quite a lot and it will come easy to you. Thank you very much for watching.